Welcome back to Math with Micah. This is Micah, and tonight we're going to be looking at an arc length problem. And we're going to be looking at this function 3 halves x to the 2/3. And for the first part of this video, we're going to be looking at the arc length of this curve from x equals 0 to x equals b. So we're looking at this from x equals 0 to x equals b. And let me remind you guys of the arc length function. And this function is going to be the integral from a to b of the square root of 1 plus our function, the derivative of it, squared. So the first thing we're going to need to find for this problem is the derivative of our function. So let's differentiate this guy. And when we do that, we bring down this exponent. So we bring down a 2/3 and we subtract 1 from our exponent up here. And these 2/3 and 3/2 cancel. Our subtracted 1 in the exponent gives us a negative 1/3 x. So that's going to be our derivative. Now let's go ahead and plug that in. And because we're finding the arc length of this from 0 to x equals b, that would mean that our bounds are going to be from 0 to b. Now we have the square root of 1 plus the derivative squared. And we just said that the derivative of this guy was x to the negative 1/3. And we're going to square that. When we square that, what do we get? We get, looks like x to the negative 2/3 plus 1. And the reason we get that, if we look at this, when we're squaring this, basically we're just going to multiply the 2 times a negative 1/3. So we have a negative 1/3 in the exponent for x, and we just multiply that by 2, and that's how we end up with x to the negative 2/3. So now we're going to have to integrate this, and this is where things get a little bit tricky. It's not necessarily super easy to see how we can integrate it as it is. So what I'm actually going to do for my arc length is I'm going to factor out a x to the negative 2/3 from each of my terms. So when I factor out a x to the negative 2/3, I get 1 for this term here, but for my 1, I now get an x to the positive 2/3. You might be thinking, how the heck do I get a positive 2/3 x from this 1? Well, 1 divided by x to the negative 2/3, remember that whenever we have a negative exponent, we can flip it to the numerator and make it positive. So let's flip it to the numerator, make it positive, and this is how we get x to the 2/3 power when we pull out this x to the negative 2/3. And from here, we know there's a property for any kind of square root that says if we have two different things that are being multiplied, a product of terms, we can split that into two separate square roots. So we're going to have x to the negative 2/3, and that's going to be multiplied by the square root of our 1 plus x to the 2/3. From here, this square root of x to the negative 2/3, to kind of see what's happening here, let's take this function, square root of, let's say, x to the 6th. Well, we know this is the same thing as the square root of x to the 3rd times x to the 3rd, which is the same thing as the square root of x to the 3rd being squared. So this cancels and we just get x to the 3rd. In other words, when we take the square root, because we have a index of 2 here, we divide this number by 2, and that's how we get 3. So we'll do the same thing with this one, and we'll divide that number by 2. And when we divide that number by 2, our x to the negative 2/3, if we divide it by 2, this numerator turns into a 1, and now we just have x to the negative 1/3. And that's being multiplied still by our 1 plus x to the 2/3 dx. From here, we can see it's going to work out really nicely if we make a u substitution. If we say, let's make u equal to my inside of the square root, so my 1 plus x to the 2/3. I like that because now if I differentiate this, I get 2/3 x to the negative 1/3 dx. And this works great because this will take out my dx here and my x to the negative 1/3. And I'm going to replace it with, let's move this over here. So let's divide by my 2/3. I now get a 3/2 when I divide by my 2/3. So I'm going to replace my 3/2 du where I had my x to the negative 1/3 dx. So let's go ahead and make that replacement. So now we have a 3/2. We said our inside is u, and now we have du. In other words, we have the integral from 0 to b of 3/2 u to the 1/2 du. Taking the integral of this, now we're going to add 1 to the exponent. So we go ahead and we add 1 to the exponent, and we get 3/2. We still had a 3/2 out front, But now we have to divide by this new exponent. So in other words, we multiply by 2/3. This would cancel it out when we take the derivative. And we see here, we get a nice, beautiful problem where these 2/3 and 3/2 cancel and give us 1. And we're going to plug in our bounds of 0 to b. But before we plug in those bounds, let's go ahead and plug back in our original u sub. And we originally said that u is equal to 1 plus x to the 2/3. And now we are golden to go ahead and plug in our bounds of 0 and b. So when we plug in our upper bound of b, we get 1 plus b to the 2/3. This is all raised to the 3/2 power. Minus, we plug in our lower bound. We plug in a 0 here. That turns into 1 plus 0 is 1, and 1 to any power is always 1. So 1 to the 3/2 is still just 1. So this would be our arc length. We'd say that it's equal to 1 plus b to the 2/3, all raised to the 3/2 minus 1. And now, how is this helpful? Well, let's say we want to find the point that we end up if we travel a total of 7 units. So let's say we are traveling 7 units along a curve, and we're starting at 0, 0. So we're traveling 7 units, and we're starting at 0, 0, and we got to find what location, what point do we end up at? Well, if I'm traveling 7 units, that means my length is equal to 7. So I can go ahead and set this arc length that we just solved for equal to 7. So I'm going to set this equal to 7. And now I want to solve for b because I want to solve for the x coordinate. Remember, our arc length was from x equals 0 to x equals b. So we don't know what this x equals b is, but we're going to solve for it when we see if we travel 7 units, where do we end up at. So let's go ahead and solve for it. We'll add 1 over here to this side. So now we have 8. To undo our 3/2 power, we can raise each of these to the 2/3 power. So we're going to go ahead and raise this to the 2/3 power. So now we have 1 plus b to the 2/3 is equal to 8 to the 2/3. And that's the same thing as saying 8 to the 1/3. And then we'll raise that to the second power. And 8 to the 1/3, the cube root of this is 2. So we have 2 squared. And 2 squared is the same thing as 4. So now we're going to keep simplifying here, and we're going to solve for b. So let's subtract 1. So we get 3 is equal to b to the 2/3. And now again, we're going to multiply each of these, or raise them to the exponent of 3/2 to cancel out with my 2/3 here. So I'm going to raise this to the 3/2. And this turns into 3 to the 3rd power, which is 27. But we have a 1/2 on the bottom. That tells us it's a square root. So this is going to be my x component. And now to find that point, we need a y, because for every point, we need an x and a y pair. So let's go ahead and plug back in square root of 27 to our original function. And our original function was 3/2 x to the 2/3. So I'm going to plug in my 27 to the 2/3 power. And we can go ahead and solve here. We see the square root and the second cancel. So we actually get 3/2 times 27 to the 1/3 power. And the cubed root of 27 works out really nice because 3 times 3 times 3 does give us 27. So we end up with 3/2 times 3, which equals 9/2. So we'd say for our answer for doing an applied problem using this arc length, we say if we travel 7 units along our curve starting at 0, 0 in the positive x direction, where do we end up? Well, we end up at square root 27, 9/2. And this would be our xy coordinate that we end up at. So that was a little bit of a walkthrough with arc length and then applying arc length. Hope that helps, and as always, leave a comment. Be sure to subscribe, and if you have any questions, email me at mathwithmicah@gmail.com. Awesome. Have a good night.